Now let's talk about abuses that happen all the time in statistics. What are abuses of statistics? Well, unfortunately, there's bad representations of data. It's up to us to use our analytical thinking skills to maybe know both sides of a situation, to do the research, or to be able to interpret that. That takes logical, analytical thinking skills, which is part of why you're taking my course or courses. So we're trying to get better at that stuff. So some of these abuses that can happen, which do unfortunately, as I said, happen all the time, maybe not all the time, but most of the time, or a lot of the time, there's some poor displays of data out there. Well, what's that mean? Well, one example is extrapolation. I saw this in a meeting that we had where, they were talking about, student population, things like that, and how we're going to rise off the charts with that. Well, that's going out of bounds, so to speak. And so, kind of like in baseball, when I tell my players, hey, you don't have to play on the line, because if it's outside the line, you don't have to field it, it's a foul ball. So come on in from third base or first base and play defense first before covering the bag. Unfortunately, there's statisticians out there that get so wrapped up in the numbers, etc., that they forget about that. One simple example, since we're in Iowa, a lot of us, the number of farmers versus the year. And if we chart this out over time and do a time plot with the connecting the dots with lines, I didn't put a scale on this, it's a made-up example, but we can see since the year 1900 we'd have had a significant decrease in the number of farmers that we have working the land. So if we extrapolate and go beyond the year 2000 to the year 2020 or beyond and try and make a prediction on this, then what happens here is we might end up extrapolating and saying, hey, this trend is going to continue and we're going to have now a negative number of farmers. Well, you and I both know that's not possible. And so this is extrapolation, which is going outside of the range of data. At some point in time, this will have to plane out and level off. There's been a lot of reasons, maybe other variables, maybe called lurking variables, things that impact this that aren't mentioned here. One was the invention of machinery and being able to operate instead of only, handling 40 acres, maybe they can handle 400 acres now because they have a bigger tractor that can do that stuff. And so we don't need as much. There's also been industrialization and, movement into cities and those types of things with technology jobs, those types of things. So operations are becoming fewer and bigger that we have here. So some of that's going on, but we're still going to need to eat. So we're still going to need farmers. And basically, this is extrapolation, which is poor representation of data. Another poor display of data might be cutting off, as I mentioned before, cutting off a scale and only showing part of the information. Maybe this is graduation rates for Iowa State, UNI, and Iowa, and you can see obviously UNI is a much better school than Iowa State and Iowa because I went there? Maybe. But anyway, this is poor representation of the data, and if I take, I'm leaving off basically 0 to 50% here. Well, if I come down here and I start at 0, you can see all of a sudden it looks a lot better. Now, once again, this is made up data. If you like Iowa State or Iowa the best or Drake, you can put them in the middle. That's fine because this data isn't real. But anyway, you can see that this is a lot better comparison. And while UNI is still potentially better with this fictitious data, here it looks like it's dominating the other two schools, and the reality it's not. It's only slightly above. So anyway, this would be a much better representation of the data. Some other things that can happen with abuses of statistics is when we do experiments or we do surveys, we can have bad sampling. Sampling, remember, is just taking a portion of the population and designing either an experiment or things like that. We also have design bias that happens. The question is, what's bias? It's not a judgment. Bias in the statistical realm is just simply systematic favoritism toward a certain outcome. It may be intentional because that's the result you want. It may be completely unintentional, but it can still happen. Some examples of bias are convenience sampling. That's bad sampling. What does that mean? If I just ask my students in Carroll, Iowa, hey, who's going to a beach for spring break? That's a bad sample. Convenience sample is convenient for me because I can just ask them, but I might have 1 out of 20 students are actually going to a beach. Why is that? Well, first of all, they're at a community college, so they're trying to save money by getting as good or better of education with less dollars out of their pocket. They're not juniors or seniors, a lot of them. They're only freshmen and sophomores. A lot of them are still living at home. Mom and dad are going to say, no, you're not going to Miami Beach for spring break. And location, location, location. We live in Iowa, is probably the farthest from any of the oceans that are out there. And the beaches around here in March are going to be probably covered with snow and ice. Okay, so voluntary response is another type of bad sampling where basically we may have a question about our president, and we may say, hey, who thinks our president's a jerk face? And let us know. Call into the radio station, and if it's Rush Limbaugh who hates Democrats and it's a Democrat president, and people are calling in, who's calling in? Mostly it's going to be Republicans calling in that are going to take that side, so it's going to look skewed against a Democratic president. Somebody like my brother who is very Democratic and he just wants to argue with people, he'll probably call in too, but those are going to be few and far between, so that can skew results. Undercoverage is when entire populations are left out. So we may ask about baking bread only during normal work hours during the day. Well, guess who's left out? The people that work for a living, things like that. Who's going to be home? Maybe older people that have grown up making their own bread. Maybe they have more time to bake their own bread. So if I'm a baking company, I might only want to ask people if they bake their own bread during normal working hours during the day, Monday through Friday. But unfortunately, that will also skew the results with undercoverage. Response bias is basically when, the responder may lie. Have you ever been grabbed at the store and been asked questions? Hey, I got a quick survey, can I ask you some questions? And they won't let you go, so you might just lie to make them happy or whatever. There could be gender bias where we're only asking males or females certain questions. You might have a color of pink and asking only guys if they like that color pink, etc. So there can be gender bias, there's etc., etc., etc. There's all kinds of problems with bad sampling and design bias. Okay, it could be wording of the questions too. Have you ever heard or seen the commercial where, hey, 2 out of 3 dentists surveyed say chew Trident sugarless gum? And then they smile, right? Well, maybe they only asked 3 dentists, and maybe the wording of the question was, hey, if your patients had a choice between Trident sugarless gum or Bubblicious sugared gum, which would you recommend? Well, 2 out of 3 of them said, well, Trident sugarless gum. So then they make that as their claim on that commercial, right? There can also be false generalizations, and basically we have to be very careful taking statistics and using it the wrong way. One thing that I have lived by and learned in my life is statistics don't apply to individuals, okay? Statistics don't apply to individuals. I feel so strongly about this, I'm going to put my signature on this. I've lived it. I've learned it. I tell other people that. Okay? So now, this isn't to say that, hey, you can go ahead and eat at McDonald's every meal and not gain any weight, not have any coronary issues, things like that. Or you can say, my great uncle lived till he was 102 and he smoked cigars and, drank and did all this stuff, and so it's okay to do that. Well, okay, that's not really what I'm talking about here. We know McDonald's food is bad for you. We know that smoking and drinking is bad for you, those types of things. So, there are some good statistics out there where we want to pay attention to those. But I'm going to tell you that if I haven't mentioned this before, my daughter, oldest daughter that I reference sometimes, she had stage 4 cancer when she wasn't quite 3 years old. And I didn't really know what stage 4 meant. I didn't really know a lot about cancer. But stage 4 is the most aggressive of any type of cancer that's out there. She had stage 4 neuroblastoma. She got so sick so fast that we didn't know if she was going to make her 3rd birthday. So when you start looking at statistics as a mathematician and somebody that was teaching stats, I said, give me all your books, give me everything you got on stage 4 neuroblastoma. I want to know all about it, everything else. And so, they got together about 20 or 25 different books and articles and journals and everything like that. And I took about 15 minutes of starting to look through some of that stuff. And I said, get that away from me. Because all it was death and destruction and no good news. So then people would come up, well, what's your daughter's prognosis? Well, what does that question mean? The question is, what do the doctors say her chances are of living? This is my little girl. What's her prognosis? So what am I supposed to say to them? Death. Is that what you want me to say? So I let them know, hey, we've got a tough battle on our hands. We're going to rely on people that have gone through this. We're going to make sure that she's part of studies and treatments and, you know, the programs and the protocols and all this stuff that I have taught is now real life for my daughter. A lot of it was out of our control. And she was randomly selected to do this type of treatment versus this type of treatment. I put it in God's hands and hey, whatever's best for my daughter. Guess what? She's 16 now. She's doing great. She's doing wonderful in school. We know that every day is a blessing. She's never considered cured because other residual cancers could come and those types of things. But at the same point in time, we're very blessed. And I do know this, back to the one that she got, they're not using that anymore because statistically this other way was better for the people, and that's fine. And I wanted to make sure that if nothing else, somebody else could benefit from her struggles and her trials and her tribulations, those types of things. But I'll tell you this, you know, the doctors, the nurses, you know, having a path to run on, that was a huge deal. But without faith in God above, there were 3 major miracles that happened that allowed my daughter to heal when it was medically impossible to heal. Faith is a very strong part of our family, and at that point in our life, and even now and every day, every week, you know, I have to give it up and know that I don't have control. Anything can happen to any one of us at any given time. I could get hit and killed driving down the highway by somebody that's texting and driving. It's almost happened where I've got hit and I see somebody texting or things like that, and I've got my kids and my family. So we need to understand that a lot of things happen to a lot of people. I'm a person, but at the same point in time, don't label me. Don't tell me I can't or I won't or things like that. So don't judge me. Don't use statistics against somebody. Give them the benefit of the doubt. And when you have no control and you have those situations in your life that are very hard or very challenging or things are not in your favor, give it up to God. Rely on your faith. And if you ever need somebody to talk to, you give me a call.